Let's say I have a ball, again, on a very smooth table with no friction. And let's say I have a force that is pushing at this ball. Okay, let's say the force is 5 newtons, just for example, and suppose that the mass of the ball is 2 kilograms, and suppose that at this particular moment when the force just started pushing, suppose that the speed of the ball is 1 meter per second. Now, so because of the force, the ball will start to go faster and faster. It will accelerate, and after a time, let's say after 3 seconds. Okay, after 3 seconds, we want to know. After 3 seconds, we want to know what is the velocity of the ball. So that's the question, right? That's the question. How can we answer such a question? Well, we can actually do that using Newton's second law. Now, I'm just going to write down F equals to ma, this simpler form of Newton's second law in SI units. We can make use of this to find the answer. Now, first of all, we need to relate this to the velocities. So we would write acceleration in the form. We can write the acceleration in the form of change in velocity v minus u over the time taken. All right, in which the v would be this final velocity that we want to find. The u would be this initial velocity of 1 meter per second. The t would be the time, and m would be the mass of 2 kilograms. So if you look at this equation now, of course, F is the force. F is the force of 5 newtons. So if you look at this information, the given information, and the force equation, you'll find that everything in the equation has been given except for v, all right, which we need to find. All right, we know the force, we know the mass, we know the time, we know the starting velocity. So v is the only unknown down here. So in principle, we can just substitute all the numbers into the known variables and then use algebra to solve for v. We can do it that way, or we can do it in 2 steps as well. We can make use of F equals to ma to first find a, and then we use the relation between a and v, u, and t to solve for v. We can do it either way. Doing it in 2 steps has the advantage that each step can be simpler. So, but doing it all at one shot requires a bit more algebra. So either way is fine. So which way should I go? Well, let me break it down in 2 steps for now to illustrate the kind of things that you get. So let me start with the f equals to ma. Okay, we know f and we know m and we want to find a. Let me find a first before I try to find v. Okay. Now, what I like to do when I have an equation like this is that if I know that I want to solve for a, I would, instead of substituting in the numbers first and then solving for a, I find it easier to solve for a first, to make a the subject, right? The reason being that if I sub in the numbers into m and f now, I have a lot more digits to carry around, which can be confusing. So solving for a, then I can solve for a in this equation by dividing both sides by m, or we can also say just by bringing m down to the other side. So anyway, so f, this gives f equals to, this gives a equals to force over the mass. And let's try to calculate this. Force over mass is 5 newtons over 2 kilograms. So 5 over 2, which is 2.5. Acceleration units are meters per second squared. Okay, so now that we have this, we now want to find v. So next we write down the relation directly between a and this formula here. Okay, so I'm going to write this out here first. So the relation is that a is equal to v minus u over t. So all the numbers are known here in this equation except for v. So what I would do is I would make v the subject before I substitute any numbers. Okay. So we can bring t over to the other side. This gives a t equals to v minus u. U there. Okay, and I want to make v the subject, so just bring u over to the other side. So, or add u to both sides. So this gives u plus at is equal to v. So now I have in a formula. I have a formula for v that I can use. So therefore, using this formula, I can substitute in v, a, and t. So let's do that. U is 1. So 1 goes into the u there. A is 2.5, goes into the a there. So plus 2.5. T, right? T is 3. Goes into the t here, so that's times 3. So we have all the numbers now, and we can calculate this. So 1 plus 2.5 times 3. 2.5 times 3 is 7.5, plus 1 is 8.5. So that is the final velocity bit. And units would be meters per second. So that's the final answer. Now it all looks quite easy in this case, and there's a reason why it looks easy. Is because in this example we so happen to have in this example the force, the initial velocity, and the final velocity all in the same direction. Okay, so if they're all in the same direction, it really means that we don't have to worry much about the direction. Just plug in the numbers and we'll get it. But what if we have a situation in which, say, maybe the force is in one direction and the velocity is in the opposite direction? things will get slightly more complicated. So just to get ready for that, let's now quickly look through this calculation and see how we should have considered the direction. But the way to consider the direction is, in this particular example, since motion is along a straight line, is to choose one direction as positive. So either the right or the left as positive. Now, it's usually natural for many people to choose the right hand side to be positive. Maybe because those people are right-handed. But it's equally fine if you want to choose the left hand side as positive. As long as you stick to it, you'll get the right answer. So okay, so if I choose the right hand side to be positive, the left hand side is negative. So what this means is that if I now go through the equation, or if I now look at the numbers given, I really need to put in plus and minus signs. So for example, 5 Newton, because it's pointing to the right, I should have a plus sign there. So it should be plus 5 Newton. Initial velocity 1 pointing to the right, so it's plus 1 u. V, don't know yet, we'll find out. T is not a vector, it's a scalar, so no signs. Or rather no directions. Okay. Mass, no direction, so we don't have to put in a sign. So we have signs for so far just F and U. Now let's run through the equation and see how we could put in this sign. A, F over M, right? So F should have sign, so that should be plus 5, okay? And the answer is A is an acceleration, has direction, so I should include the sign. So, but that sign would be decided by the plus 5 over 2, so therefore it's plus 2.5 for the acceleration. And then we come here, right? So we have U plus AT that we need to find. So both U and A have directions. A, we just found that it's a plus, and U is a plus as well. So those two are plus, so that's a plus and that's a plus, right? Because they are plus, I can just add the numbers directly. So you can see why it's quite straightforward, because they're just plus signs. And in the end, we get an 8.5, and again, it's a plus because it's not a minus. All right, in this case, that sign is decided by this calculation. So the calculation gives us a positive answer, so it means that V is plus, and then we can describe our answer. We can say that V, the velocity V, has a magnitude of 8.5, and its direction is to the right. Okay, it is to the right. Now, you might, if you remember, I said just now that it really doesn't matter whether I choose right hand side or left hand side to be positive. Now, that might sound a bit strange at first, because what if I've instead chosen the left hand side to be positive? Okay, suppose that instead of what I've just done, I choose left hand side to be plus and right hand side to be minus. If I do that and I run through everything, I'll end up with okay, instead of a plus for the acceleration, I end up with a minus. Okay, so instead of a plus for my final answer V, I'll end up with a minus 8.5. So you might wonder, surely if I get minus 8.5 as the answer, okay, surely that's different from plus 8.5. That is true, or that is absolutely true, but it's just that when I say the final answer is the same, I wasn't actually talking about whether it's plus 8.5 or minus 8.5 as such. I wasn't just talking about the number and the sign. I was talking about the description of the velocity. So if you get minus 8.5, how would you describe the answer? You would say that the velocity is 8.5 meters per second in magnitude. To which direction? Okay, let's see. Minus, in my new convention for the sign, my minus is to the right. Okay, so I would say that the magnitude, that the velocity, I would describe the velocity as 8.5 meters per second to the right. Now, when I do the description part, I can forget about the sign. All right, I don't need the sign to do the description. I can just say 8.5 meters per second to the right. And as you can see, whether it's plus or minus, it is 8.5 meters per second to the right. So that's what that is what I meant when I said that. Whether you choose the right hand side to be plus or the left hand side to be plus, you will get the correct answer. And the correct answer is 8.5 meters per second to the right.